Okay, so there was only one problem solving request this week. Y'all only had this one homework to do in webwork today, homework 11. It was a little unclear from the request if I should be doing problem 1 or problem 2. It said like problem 1 in the subject, but problem 2 in the body. But the body mentioned imaginary roots, and I checked, and problem 1 has imaginary roots, so I decided to do that one. Problem 2 does not have imaginary roots. I'll go ahead and give a spoiler, that's going to be a repeated root problem. So, working on problem 1, we've got this ODE to solve. X cubed y triple prime minus 2x squared y double prime plus 12xy prime minus 30y equal to 0. And webwork gives you this big formula that you can plug in, but the way that you can remember how to do this problem is just to say, okay, I think y is x to some power, because this is a Cauchy-Euler formula with powers of x that match the derivative I'm thinking about. So that's going to give me y prime is mx to the m minus 1, y double prime is m times m minus 1, x to the m minus 2, and y triple prime is m times m minus 1 times m minus 2, x to the m minus 3. So when I plug that into my ODE, I'm going to get that 0 would be x cubed times m minus 1 times m minus 2, x to the m minus 3, because that's y triple prime, minus 2x squared m times m minus 1, x to the m minus 2, because that's y double prime, plus 12x m x to the m minus 1, because that's y prime, minus 30x to the m, because that's what I assumed y would be. Oh, and I see on the left here I am cutting off things just a little bit. Okay. Pushed my problem to the right. There we go, that should be fine now. Gotta not do that. All right, so now I'm going to start to try and simplify this into that algebraic equation that I solved for m. What I'm going to notice is that x cubed times x to the m minus 3 is going to give me x to the m. X squared times x to the m minus 2 is going to give me x to the m. X times x to the m minus 1 is x to the m, and here I've got x to the m. So what I actually have is every single term has that x to the m, and then what's left over is everything that's not a function of x. So all I've done is factor out that x to the m that's in every term. If you're not totally convinced about this multiplication, go ahead and try it for like a number that's easy to count to, and you should be able to see that this happens with powers. And then I can divide out that x to the m, or I can think about how if this has to be equal to 0 for every single x, then I must have that this thing is 0, because I'm only guaranteed to make this 0 from the x when x is 0. And in either case, I get to the point where 0 is m times m minus 1 times m minus 2, minus 2m times m minus 1, plus 12m minus 30. And then I just have to start factoring stuff out, or multiplying things out, sorry. Let me make sure I didn't make any mistakes there. That's looking okay to me so far. Be careful with this minus times a minus. Usually when you all have worked deep into a problem and are getting it wrong, and I come by to check your work, it's because this multiplication kept a negative instead of making it positive. Now I can't erase that. Okay, and then I want to combine like terms. I'm going to have to solve this eventually, so I want it to be as simple as possible. I've got m cubed, and then my m squared terms are there, so I'm going to get minus 3 minus 5 is minus 3 minus 2 is minus 5. m squared. And then for just my regular m terms, I've got this, this, and this. So 12 plus 2 plus 2 is going to give me 16. I'm gonna and then there's only one term without an m in it, and it's that minus 30. So this is my auxiliary equation. That I'm trying to plug in here. So it's going to be m cubed. Oh, sorry. They are using the letter r. R cubed minus 5r squared plus 16r minus 30. Let's see if that's right. It is. All my factoring and multiplying out didn't make any mistakes, so we're good there. And then we have to find the roots of this. Since it's a third order equation, I should have 3 roots. And as I told you all, you won't need to factor cubic equations on the exam because that's difficult. Instead of spending all night tonight trying to factor your third order equation, you could go ahead and like check out a calculator. When I look at this one, I'm pretty sure this one had 3 as one of the roots. Let's just go ahead and do it to be sure. Roots of that. Yep, 3 is one of the roots. So let's go ahead and, oh, wrong window. Let's go ahead and factor out that it looks like 3 is a root, and then after that I'll have to figure out what's left over and try to factor that. I'm going to go ahead and go to the next page to do that long division. So I had m cubed minus 5m squared plus 16m minus 30, and I am trying to see if 3 is going to go into that. So first, to get rid of my m cubed, I'm going to have a factor m squared minus 3m squared. So that's going to give me minus 2m squared plus 16m minus 30 left over. That minus was like for that term in parentheses. So this became minus 5 plus 3 was minus 2. So next I'm going to take minus 2m. That'll get me my minus 2m squared. Yeah, that should work. Then plus 2 times 3 is 6m. And if I'm subtracting that off, I'm going to get 0. Again, my first term cancels. And then 10m minus 30. And then I'm going to do plus 10. So then I'm going to get 10m minus 30. And when I subtract that off, I'll get 0. So, however you learned how to do this in school is fine. But at this point, I know that I could factor this as m minus 3 and m squared minus 2m plus 10. So already I've got that m equals 3 as a root, although I'm not quite ready to use that because I also have to figure out what 2 roots come out of this. If I try to factor it, I run into the problem that in order to make 10 with like 1 times 10 or 2 times 5, I can't get a difference, negative 2. Those differences come in like 8 and 3, so that's never going to work. And so at some point I would realize that I'm going to have to use the quadratic formula on this. So we're at m equals 3 and m equals question mark. But I know I can use the quadratic formula. So then I'm going to go ahead and say, okay, for quadratic formula, it's this, where my coefficients A, B, and C are whatever appears in the first, second, third terms there. So for us, that's going to be B is -2, A is 1, and C is 10. So I'm going to get minus minus 2 is 2, plus or minus the square root of -2 squared is 4. Actually, I will go ahead and leave that. That way you can see where it came from. -2 squared. -4 times A is 1 times C is 10 over 2 times A is 1. So simplifying, I've got 4 plus or minus root 4 minus 40 over 2. 4 plus or minus 6i over 2 is what that looks like. Because 4 minus 40 is 36, so square root -36 is 6 times an imaginary number. So what I'm getting here is that this is 2 plus or minus 3i. So let's go ahead and try putting these roots that I found. I guess I should say this means my roots are m equals 3, 2 plus 3i, and 2 minus 3i. And I sure hope nothing went wrong in my algebra here. So 3 comma 2 plus 3i, 2 minus 3i. No, oh, my second and third numbers are wrong. Let's see. Okay, super easy thing. I took minus minus 2 and made it 4 here. That was silly. A lot of you in class are used to having something like that we gotta fix throughout the course of class. Always so frustrating when it happens. 2 over 2 is 1. So I just copied down. This should have been 2, not 4. And that kind of went through my whole answer. Let's see if that is correct. Yes, okay, phew. Okay, so those are my roots. M equals 3, 1 plus 3i, 1 minus 3i. And then from here, we're just asked to list the fundamental set of solutions. Remember, we started this whole process by assuming y is x to the m. So your first thought would be, okay, I guess it's x to the 3, x to the 1 plus 3i, x to the 1 minus 3i. But then we also remember we don't like solutions to have imaginary numbers, so we use those special complex functions that are like the same thing. Where we've got the x to the alpha sine ln, no, I need my beta. Beta ln x, I think, and x to the alpha cosine of beta ln x. Those should be like in your notes right after the steps to solve this type of problem, and on your exam that's going to be on your formula sheet, that complex form. So for m equal 1 plus 3i, I've got alpha is 1, beta is 3. So in those cases, I would have x to the 3 and then x to the 1 sine of 3 ln x. and x to the 1 cosine of 3 ln x. So that's my fundamental set of solutions. There's 3 of them because this is a third order equation. We might have to fight webwork for formatting. We'll see. Nope, it's fine with that formatting. It saw all the parentheses it needed. Okay, cool. And then the last thing is that we just need to find the general solution with arbitrary unknown constants a, b, c. A lot of the time in my examples, I'll call those C1, C2, C3. We'll say like you do C1, Y1 plus C2, Y2 plus C3, Y3. It's just a quirk of webwork formatting that we got to do A, B, C. So I'm going to have a x cubed plus b x sine of 3 ln x plus c x cosine of 3 ln x. And we're not asked to solve this system of equations. Oh no, I've bumped that again.